Let's look at number 14. It says find the derivative. Again, I'll color coordinate it. Y is equal to the natural log of x squared minus 4, and I'm going to put that to the 1/2. Notice that there is multiplication here. Big mistake people make right now. What do you think that they do? They distribute this. You cannot distribute that, because that would be like trying to distribute that. This is not going to be 3x minus 12, because it doesn't distribute within a summation of something. That subtraction inside the radical says you can't do that. Yes?
Did you distribute like an x squared into?
No, not even. So when you can distribute something is the following. You can only distribute it basically whenever there's multiplication everywhere. So if it was like this, look, x times 4 square rooted, that's the same as this. Okay? So even so, I see what you're asking now. You wouldn't be able to distribute this like that. 3x times 12 and then square root it. PEMDAS says we would have to take the square root first of both the 4 and the x, and then we would multiply the 3. So it would just be the square root of 4 is 2, so 6 square roots of x. Algebra 2, okay? Know when and where you can distribute stuff with powers and, you know what I'm saying, with summation pieces and stuff. Alright, so let's go ahead and go to the derivative. Where do I start?
1 over the stuff.
Yep, 1 over the stuff. Okay? Again, I'm going to put multiplication so that you see the two monomial pieces. Times the derivative of the stuff. What rule do I approach the derivative of the stuff? Product rule, yeah, multiplication. Product rule. So it's going to be first times the derivative of the second. Watch this chain rule. 1/2 of the stuff to the negative 1/2 times the derivative of the cream. All of that is the derivative of the second piece. You've done this before, okay? You're just getting back to the practice.
Would the coefficient change, or the exponent, the negative 1/2?
It did. It did. You see that negative? Okay, so first times the derivative of the second plus the second, okay, times the derivative of the first, which is just 1. Can you see it?
Yeah, but doesn't, whenever you do the chain rule, doesn't you bring it down? You did do 1/2.
I did. It's right there. I just didn't bring it down yet. I'm just leaving it. You're right. I see what you're saying now. You're saying to rewrite it with it in the denominator already. Yeah, well, we could do that here in just a bit. You're right.
Okay.
Yes.
Would that be acceptable, or do you have to simplify from there?
This is totally acceptable in WebAssign. Remember that. You don't have to simplify in WebAssign.
Oh yeah, I forgot the negative exponent.
Yeah, the negative exponent, it will interpret that. But we're going to do it by hand because on the test I want you to change that negative because I don't want to count off for the negative. And why? Because you need the algebraic manipulation.
But if that wasn't negative, you would accept that
Correct.
as is?
So, here we go. Watch, here we go. So, okay, so let's keep going. We're going to simplify it like Ben was saying, because on the test you're not allowed to have a negative. And I know it's been a while. I mean, it's been a while since we've done a lot of this kind of algebraic manipulation, okay? So, get back into practice. Looking at all this piece right here, what I would notice is the fact that I have a 1/2 and a 2 being multiplied. So those will do what to each other? Cancel. Okay? So then I'll look at my numerators. All of these, which I should use a different color, all of these right here that are highlighted in blue are going to be my numerator pieces. Do you see them? So this right here would be x squared And on the bottom, just like Ben was saying, we would move this down here with a positive 1/2. Let's now multiply this in. And notice this, as I multiply this in, this piece and this piece, what are their powers going to do? They're going to add and become what number? 1. Yes?
I'm confused. Don't like wouldn't there be parentheses around the entire cream
True,
from
but
natural log?
yeah, there would be parentheses right here, but when you're multiplying, they're going to fuse together anyway.
So what about the plus?
That's adding. We don't fuse those together. We only fuse through multiplication. Multiplication can bring pieces of clay and create a bigger piece of clay. The addition and subtraction pieces, they're separate islands, if you will.
You're saying like, isn't that all the same thing? So you need to combine that before you multiply. Like he's saying, shouldn't you add all this stuff in the right
Oh, nice job. Nice job, nice catch. You see what he's saying? He's saying that this right here is the derivative of the cream. Nice job, Brooks. Nice catch. Nice job, Jacob, as well. So all of this is the derivative of the cream. So this would be distribute to this first term right here. And it would also distribute to this other term right here. Okay? Again, it's been a while. So when I distribute this, we see that this 1/2 and this 1/2 are going to cancel out to 1. So let's put 1 right here. We'll put x squared minus 4 to the power of 1. Those 2's cancel just like we showed before. Those x's became that x squared that I'm color coordinating. And I still have to multiply this x right here, whoops, down into the denominator. Right here. Now when I multiply that x back in, can it cancel with the x squared? Okay, so this will cancel and no longer do you have x squared. And yes, you still have to distribute to the other piece, just like Brooke said. Okay, looking at this, if I distribute this piece, what does the x plus x squared minus 4 squared, or square rooted, what do those pieces do to each other? They cancel each other out, right? They cancel to a form of 1. So what is my fraction going to be right over here? Anyway, 1 over x. Nicely done. Nice job following too, even with the detour. So our final answer is going to be x over x squared minus 4 plus 1 over x. This is an acceptable algebraic manipulation that's equivalent to our big answer.
Didn't you already cancel out that x squared minus 4 to the negative 1/2 in the denominator?
What?
Like, because when you got that 1 over x, you're saying the x squared minus 4 to the negative 1/2 times the x squared minus 4 to the 1/2. But
Yeah,
didn't
so
you
those
already-
cancel. So let me highlight it even more. This distributed with this. Do you see how this is in the numerator and this is in the denominator?
Yeah.
Those will cancel. So what's left is 1 over x. Do you not see that?
But don't you add it before you even multiply it with that?
So look,
How is
x,
that equal to the
let's say x squared, and this distributes. This would give me x cubed plus 2x squared, right? All we're doing is just the second distribution. All of this distributed with the second piece.
No, I see that, but I like you said like the x squared minus 4 to the
This,
yeah.
it didn't cancel, it became 1 because this
No,
right.
But like when you said the 1 over x, like you said you were using the negative misspoke and I
Oh, okay.
ditched this, but yeah.
How is it equivalent to your answer? Is that what I heard someone ask?
No.
It's just another manipulation form, but it is equivalent.
So if you put your answer in, you count it right?
Yep, it would count it right into WebAssign. Because let's say the answer of WebAssign was X. But you did all these calculations and you got something that looked like this. Would they be equivalent? Yeah. So just because it doesn't look nowhere close to, it still can be equivalent. And WebAssign would accept all different types of different answers that are equivalent mathematically. Okay? Questions? Okay. That one was a good one too, you guys.